Let us see here the sync pulse. Sync pulses are to control the horizontal and vertical oscillators. The sync pulses are first separated, then sent to corresponding horizontal and vertical oscillator. How this sync pulse is separated? If you see the black burst here, the black burst had three parts: the horizontal sync, the horizontal blanking, and the color burst. The amplitude of horizontal sync is same as that of the color burst, but the duration of horizontal sync is 4.8 microsecond, while the duration of color burst is 2.5 microsecond. The sync is separated from the color burst on the basis of amplitude, while the burst is separated by knocking down the color burst through Sand-Kelsis pulse. Why it is called Sand-Kelsis pulse? If you see the shape, it look like say castle. It contains the 2.5 microsecond pulse width to knock down the color burst. At the same time, to stabilize the burst gate circuit, it contains the sync pulse duration, which is of 4.8 microsecond, and also the blanking pulse duration, which is of 12 microsecond. Therefore, this separated sync pulse now is available to lock the horizontal and vertical oscillators. What is the condition of sync pulse separation? Though we have shown you the sync pulse separation by animation, but for separation it has certain conditions. And what are these conditions? The detected signal should have the sufficient amplitude, because the sync separation is based on amplitude, and the amplitude of sync pulses is to be maintained at 25% of the video signal. Let us come to video detector and the video amplifier stages. I have already told you that the video amplifier is required to raise the signal level. It has also been explained that as and when any input signal passes from any amplifier, it develops 180 degree out of phase signal. Therefore, the shape of input video is just opposite to the output video, and this output video goes to sync separator. Sync separator get the information from the video amplifier as well as the inverted pulses from the noise canceller, because if you invert these two pulses, they will cancel each other. The sync separator, which is the topic of discussion, get the video signal from the video amplifier in the inverted form. And this sink separator separate the combined sink. Composite sink contains the horizontal and vertical sink components. Your horizontal and vertical oscillator may not accept the composite sink pulse. Therefore, for the need of vertical oscillator, the pulse is integrated through the low pass filter, and to satisfy the need of horizontal oscillator, the same pulse is differentiated through the high pass filter. And this black burst, which contains the horizontal sink, is needed for the horizontal oscillator. But horizontal oscillator will not accept the horizontal sink in the same form. It means you have to find out the process how the horizontal oscillator will accept this horizontal sink. That was the animation, how to take out the horizontal sink. Now, through this circuit, let us see how the sink is separated or sink is clipped. Basically, this is a sink separator stage, which has one active device as a transistor and two components C1 and R1. They are for the biasing purpose of the base of this transistor. Here in this figure, the C1 is of the value of 2 microfarad and the R1 is of 56 kilo ohm. Composite video signal enters in this transistor and sinks are separated. But how these sinks are separated? There should be some region. This transistor comes in conduction only when the amplitude of the sink pulses reaches to 75% of the video signal, and the remaining 25% signal of the video signal bring this transistor into conduction, with the result the base of this transistor is forward with the help of sink pulses and goes into conduction, and sinks are separated. Let us see here the working principle of sink separation. This is video signal of 100% level, out of which the 25% level of the sink pulse is to be cut. And how to cut? The sink separated transistor is biased, and the biasing is done between the collector current and the collector voltage. In the linear portion of this curve, these pulses bring the transistor into conduction and the sink pulses are clipped and available for horizontal oscillator or for vertical oscillator. And the biasing done by C1 and R1 resistance and capacitance is known as a automatic biasing, and this biasing clips the top portion of the video signal, which causes to current flow in the transistor. See here again, this is that capacitor and this is that resistance, and they form the automatic biasing for this transistor. Till the sink label is available, the base of transistor is in cutoff region. As soon as the sink pulse level comes, the base and emitter goes forward bias and transistor come in conduction, and accordingly sink pulse is taken out. If you see here again, the biasing has been given to collector, but there is no biasing for the base, and base is automatically biased by sink pulses. Let us see the process, how these sink pulses are separated. Here the same capacitor C1, which is of 2 microfarad, and the resistance which is of 56 kilo ohm. They have given the biasing as a self bias to this transistor, and the collector of this transistor is biased through the supply. It is a active device. Transistor is a active device. It means it has the capability to delay the signal. Any active device adds the delay period according to frequency, and the output is available here, and input entering through the input label has delay. Here we will see how the video signal is entering in this sink separator and how it comes out from the collector of this transistor. The self biasing through C1 and R1 maintains the label. See here again, the composite video signal is entering here at the base and going through the sink separation, and after a delay this comes out from the collector. As and when this video signal is entering, it is not coming out at the same time from the collector. There is some delay. So, you have seen the sink separation, and who is responsible for sink separation? the same two, resistance and capacitance, they form the time constant, and the time constant is represented by R 1 into C 1. The resistance which was of 56 kilo ohm and the capacitance of 2 microfarad. Let us see what is the time constant. The time constant is coming 0.11 second. Whether this duration is sufficient for the sink separation, we will discuss here again. This resistance and the capacitance which have formed the time constant of 0.11 second will satisfy the requirement of sink separation. What are the conditions and what should be the value of these resistance and capacitance for correct time constant? If the value of resistance is too large, it will not allow the capacitance to fully charge. If the value of resistance is too small, the capacitance will be charged immediately fully. Then what it will do? It will pass the blanking and video along with the sink. Our aim was to cut only the sink pulses. Therefore, exact value of resistance and capacitance is required to make the complete synchronization. When we talk about the complete synchronization, we mean to horizontal and vertical timings. Any change in timings will affect the synchronization. So far we have been talking about the sink separation in analog form. What about in digital format? We know that we have separated the sink when the video signal is of a amplitude in which 25% level of the video signal is meant for the sink pulses. If we do not maintain the 25% level of the video signal as a sink, we may not be in a position to separate the sink. But whether the same condition is for the digital video sink, it is different. Sink separation as a video level is same, but the timings are different. Through the counters, this counter maintains the exact timing of sink pulses. I mean to say, if the frequency of either horizontal or vertical oscillator or even phase changes, the position of sink pulses will differ and we may not get the sink pulses. Therefore, in case of the digital video, exact timings are needed. But where are these sink separator, oscillators inside your television? In present television, all these stages are inside a IC. We have taken out one circuit which contains the sink separator, noise gate, line oscillator, etc. The composite video signal enter this IC through this inverter transistor and goes to sink separator. The horizontal means line drive and the vertical sink are sent to other stages.